Welcome to STEMPunX.
Welcome to STEMPunX. STEMPunX is a bi-monthly podcast intended to bring science,
technology,
engineering, and math straight to your ears from our STEMPunX studio. Hang on, we'll take you for a ride that includes a whole lot of fun and a little bit of education on the side. Stay tuned.
Nice to be in orbit.
Hello and welcome to the STEMPunX Podcast. My name is Joe Garoutte and I will be your host. With me as always is my buddy STEMbot. Hello, STEMbot.
Hello, Joe.
You know, STEMbot, I read the other day that we are running out of helium. I read that a large party store chain was closing 45 of its stores because of it. Now, I found out later that the headline was a bit misleading as to why exactly the stores were closing, but it made me curious about helium and its finite availability.
Joe, you are wise to be curious. Once the world's helium is depleted, we cannot create anymore. It is not something we yet have the technology to manufacture.
Just like so many things on our planet, STEMbot, if we don't truly appreciate and treasure them as part of our delicate ecosystem, we will suffer the consequences in the future. So we all know helium is something that goes into party balloons and makes our voices sound funny. Actually, they sound a little bit like you, STEMbot.
Oh, Joe, I don't know what you're talking about.
Well, let's talk just a little bit about helium, how it's made, and some of its more important uses. Helium is named for the Greek titan of the sun, Helios, and was first detected during a solar eclipse in 1868, though its formal discovery was from decaying uranium ore in 1895. It is a colorless, odorless, tasteless, non-toxic, inert, monatomic gas. Now, monatomic gas is a new term for me. STEMbot, what is the definition of monatomic?
It is a gas in which atoms are not bound to each other. The behavior of monatomic gas is free of any rotational or vibrational energy.
Well, that sounds kind of simple, but I'll bet there's more to it. STEMbot, will you please put a link in the show notes for that?
Sure, Joe.
Helium is created in one of two ways. The first is nuclear fusion. That type of reaction occurs at the core of the sun and at a volume of 620 million metric tons per second. It is the fuel on which our solar system relies for its very survival. The second method is through radioactive decay, wherein an element decays and by doing so releases mass and becomes something else. For example, when the uranium ore cleveite decays and releases A particles, which are made up of 2 neutrons and 2 protons. Those A particles pick up 2 electrons as they encounter the environment they move through, and then we have helium. Some of it escapes into the air and keeps going until it reaches outer space. Some finds its way into petroleum products, which we are then able to extract. However, this natural process takes thousands of years to generate significant quantities of helium. Helium is a combination of 2 isotopes, helium-4 and helium-3. Helium-4 makes up over 99.99% of the element, and that means the ratio is only 137 atoms of helium-3 per 1 million total. I learned that helium exhibits interesting properties when it is cooled below 5.2 Kelvin to form a liquid. The Kelvin scale for temperature has a null point of absolute 0, so 5.2 Kelvin is pretty cold.
Yes, it is, Joe. 0 Kelvin is the equivalent of negative 273.15 degrees Celsius and negative 459.67 degrees Fahrenheit.
Whoa, thank you, STEMbot. You know, even at absolute 0, helium does not condense to form a solid. Helium is the only element that won't freeze without special atmospheric changes. Not only that, but below 2 Kelvin, it has almost no viscosity, which means that it has what is called superfluidity. Superfluidity is a state in which something, due to lack of resistance, can flow without the loss of kinetic energy. If you were to stir liquid helium, it would continue circling forever. That's pretty cool. Since the supercooled helium flows with no resistance, it generates no heat and is easier to keep at that needed low temperature. Now, why would we need to keep it that cold? Well, for superconductors. Superconductors, like a superfluid liquid, have no resistance. In the case of superconductors, they lack resistance to electrical current. When a massive amount of current is necessary, we need superconductors in order for it to happen. In order for superconductors to work, they must be cold. Liquid helium cold. Liquid helium is used in cryogenics, particularly in the cooling of superconducting magnets, with the main commercial application being in MRI scanners. The largest application of this technology to date has been to create a massive magnetic field in the U.S. National High Magnetic Field Laboratory at the University of Florida.
That magnet produces a magnetic field that is 1.5 million times larger than the Earth's magnetic field.
Well, that's incredible, STEMBot. What are some of helium's other industrial uses?
It's used as a pressurizing and purge gas for rockets, as a protective atmosphere for arc welding, and in processes such as growing crystals to make silicone wafers. Since helium is lighter than air, it can be used to inflate airships, blimps, and balloons, providing lift. Although hydrogen is cheaper and more buoyant, helium is preferred as it is non-flammable and therefore safer.
Yeah, and in fact, the reason the tragedy of the Hindenburg occurred is because of the Helium Act of 1925. It had two purposes. It created a national helium reserve at Amarillo, Texas, and it banned the export of helium. Because of that ban and the U.S.'s monopoly on helium, airships such as the Hindenburg were forced to use hydrogen as their lifting gas. Well, because of hydrogen's high flammability, this led to the Hindenburg disaster on May 6, 1937. On a more positive note, we also use helium to cool the Large Hadron Collider at CERN, which is the world's largest and most powerful particle accelerator. It consists of a nearly 17-mile ring of superconducting magnets. It uses 96 metric tons of liquid helium to stay cool. And you know, some other ways we use helium might be more familiar. Divers and those working under pressure use mixes of helium, oxygen, and nitrogen to breathe underwater. And the gas is even used in solar telescopes to prevent the heating of air in the space between the lenses, which reduces the distorting effects of temperature variations. Helium is kind of a big deal. So, are we really running out? Well, it's a finite resource, so yes, we are consuming it faster than it is being produced. Should we care? Well, I think so. Total consumption of any natural resource is tragic. The National Helium Reserve has an amount of helium that, due to the dollars needed to manage it, they are shockingly trying to deplete. This saga is too long for our short version podcast, but I'll include links in the show notes. In many cases, there are ways to recycle a portion of the helium used, so there does appear to be a few choices that could be made to slow the inevitable. As always, being informed allows us to make better decisions and make positive progress. Now, it's time to say goodbye, STEMBot.
Goodbye, STEMBot.
Thank you all for listening to the STEMPunX Podcast. The STEMPunX Podcast is brought to you by Cottywomple Creative. A cottywomple is a purposeful journey towards a vague destination. Float along the breeze on a cottywomple and have them create some magical art just for you. See their work at cottywomplecreative.com. And many thanks to our patrons on Patreon. You are the helium that keeps us afloat. Thank you all for your continued support. Please share widely so that we can float along giving STEM information to everyone. And a shout out to the Columbia Gorge Orchestra Association. We are so happy to help support them, and we're very thankful that they gave us a nice little shout out at their most recent successful event, Jukebox Live. We look forward to that event next year. Thanks again for listening. Bye now.